Hi Year 12s and Year 11s. Welcome to the second video on limits, and today we're going to look at finding the limit as x tends towards infinity, which is a little bit different from what we were looking at before because the other numbers you can actually evaluate directly, whereas infinity there's no way to write that, say, in your calculator for instance. And so what we're going to do is we're going to try to evaluate this using an approximation of infinity. So how do you approximate infinity? Well, you just use really big numbers. So let's start with a number like 100,000. So I'm going to put this function into my calculator, and instead of x, I'm going to write 100,000. So on the top I'll have 2 times 100,000 minus 4, and on the bottom I'm going to have 100,000 plus 1. So that gives me 1.9999. So let's see what we get if I put in an even larger number, such as 1 million. So I'll go back and put another 0 into my 100,000s, and we get 1.99999. So 5 nines. Okay, we'll do one more. Let's try 10 million. So we're approximating infinity with 10 million. Now I'm going to put another 0 in each of my millions to make it 10 million. And we get 1.999999, so 6 nines. So hopefully what you can see here is it's getting closer and closer to 2. And so we say that the limit as x tends to infinity of 2x minus 4 over x plus 1 is 2. And if you look a little bit more closely, it actually makes sense, because as these numbers for x get bigger and bigger, the plus 1 becomes less and less significant, and likewise the minus 4 becomes less and less significant. So really all that you're left with is 2x over 2, which just simplifies to 2 anyway. Okay, let's have a look at our next example. And this example here, we've got some x squareds in it, and that presents a problem because as soon as you do something like, say, 100,000 squared, you're getting into some really big numbers, and it can quite quickly get to the stage that your calculator can't easily deal with it. So what we're going to do is inspect this function and look at its individual elements and think about what would happen to them as we go into really big numbers. So as we go into really big numbers, this plus 3 and this minus 1 really become very insignificant. And when you square a number, that gets big much more quickly than a non-squared number. And so in effect what that means is that also the 5x and the 4x become relatively insignificant as well. And so as it turns out, this limit is actually going to be the same as the limit of just x squared over 3x squared. And we can see here that we could simplify that, and it's going to be just 1 over 3. So there is a way to directly evaluate these limits as well, where you're just using a little bit of logic to see that some of these parts of the function become completely insignificant when you're going towards infinity. So I've got some exercises underneath for you to try as well, where you're going to have to think about what's happening to these functions. It's not going to be just a matter of, following a particular method. You're going to have to think, well, what's happening as these numbers tend towards infinity, and you're going to be evaluating that way. Okay, I'll let you get on with that now.